Again, simple sounding question, but two steps are involved, as we'll see when we get through it. Simple scenario, wind changes the velocity of a glider from 25 meters per second east, starts going 25 meters per second west. That happens in 10 seconds. So it goes 25 meters per second west, ends up going 25 meters per second west, starting from 25 meters per second east. All that happens in 10 seconds. Calculate the final position. Where did it end up from its starting point? Any guesses based on the numbers? Close. Not -5. Oh, your acceleration, yes, is -5. Where did it end up? Before we even do the math, if it has to go from +25 to -25, where do you think it ended up? What's that? Almost. Good idea. But because this is the opposite direction, it's not 50 meters from where it ended up. If this was like a positive, it would end up there. But it ends up back at its starting point. And so it starts out going 25. It has to lose all of that 25 and then gain another 25 meters per second west. So it ends up back at its starting point. The math will show you how that matches up. All right, so we define our coordinate system. West is negative, east is positive. Let's write down the information that we know. Initial velocity, 25 meters per second east. Final velocity, -25. And all that happens in 10 seconds. So initial velocity, 25 east. Final velocity, let's go straight to making everything relative to going east. -25, acceleration is 10, excuse me, time is 10, acceleration is what we are looking for. I'm sorry, we don't even know we're looking for acceleration. I got ahead of myself. Spoiler alert, we need to find acceleration. Reading the question, it's asking us to calculate final position. So writing down what I know, what I'm asked, I'm looking for final position. I'm not given anything about initial position, so it's 0. So based on the information given and the question that's asked, what formula would I use? What mathematical relationship can I use here? And the trick is when you look, there isn't one formula that's set up to solve this problem. Okay? So you could sit there for an hour looking at your formulas. Unless you're doing some math and some algebra, you could create your own formula, but there's no such formula that relates any of these so that we could calculate final position. If you look at your formula to calculate final position for something that's change in velocity, you need the acceleration. The process here is to look for a formula that's close. So you're just looking at your formula. I'm trying to solve for final position. So there's two formulas for final position. Look at those. Is there anything that's missing? Like look at the variables that you have, and is there one or two variables missing? So we're looking at the same formula we used the last problem. Looking at that, all we're missing is acceleration. We're just missing that acceleration. Then think, well, is there a way to calculate what's missing? I'm like, yeah, we can do that with our acceleration formula because we have final velocity, we have initial velocity, and we have time. Right? We've got all those. So now we can solve for acceleration. So that's where I'm getting at with solving acceleration. As I promised, final velocity, -25. Initial velocity is 25, 10 seconds. So it changes its velocity by -50. You might think 0, where it goes from 25 and then back in the opposite direction 25, but that change is -50. Acceleration -5 meters per second squared. So that's a number we're using. Now we're going to use that value in the equation from above for final position. Final position is going to be initial position, 0. Initial velocity, +25. Time, 10 seconds, plus 1/2. Acceleration, we now have that, -5. Time, 10 seconds. That's squared. So again, careful with your math. Final position, 25 times 10 is 250. 10 squared is 100. 100 times -5, -500, half of that, -250. So it loses 250 meters of position because of the acceleration being negative. So whatever it gained, it had lost. So final position is right back at the starting place, 0 meters. And that might take a day or so to kind of sink in how something can be moving and experience an acceleration, but back at its starting position. It just kind of went one direction, turned around, came back, and it took 10 seconds. It's at position 0. So average velocity, if we considered average velocity, it would be 0. But that's average, not instantaneous. It's still moving.